Chapter 6, Lesson 3 deals with rotations. Another one of our transformations on the coordinate plane. A rotation is a turn around a center. And it's important to note that the distance from the center to any point on the shape stays the same throughout the entire transformation. Now, we are specifically dealing with rotations around the origin. We could have rotations around any given point, but for the purposes of our class, we're sticking with just the origin. Let's start by looking at a 90-degree clockwise turn about the origin. A special thing to note is you could be given directions whether it's clockwise or counterclockwise. So it's important that we know that 90 degrees clockwise is the exact same thing as saying 270 degrees clockwise. If we were to talk about a turn like each of those, I'm just going to make a small grid. And say I have this point here. A 90-degree turn would take it from the first to the second quadrant. Let me change the direction on that. Sorry, I'm used to going to counterclockwise first. So here's the X again. A 90-degree clockwise turn puts it down below. But if I were to look at what a 270-degree turn counterclockwise was, it'd look like the following. This would be 90, 180, now 270. It puts me in the same location on the graph. That is why we note that a 90-degree clockwise turn is the same thing as a 270 counterclockwise turn. Over here on the left, we have our rule, and that rule is that we take X and Y, we switch their order, and make the X a negative, or as we talked about today, the opposite of X. So it's important to note that we will change the sign of the X so it becomes the opposite of X and switch the order. Let's use that below first to find our new ordered pairs, and then we will go ahead and graph it on the coordinate plane. First, we'll look at the point A, and we'll change it into A prime. Well, we need to first switch that order, so it's 3, comma. But before we write that X, we need to remember that we're going to change the sign from a negative to a positive. Let's do that again for B prime. Instead of 1, comma 4, we'll switch them to say 4, comma, but also make the 1 negative. And again for C prime, we'll swap them, so 1, comma 3, but now the 3 has to be a negative. And now let's put that on the graph to see what it looks like. So we have this triangle. We're going 90-degree clockwise. Remember, clockwise is when you go, I apologize. Clockwise is a turn like this. So we get an idea of how this triangle might turn. We'll start with our 3, comma 7. Place the point here. That'll be that tip of our triangle. 4, negative 1, and 1, negative 3. And when I connect the dots, I now have a new copy of my triangle. I apologize. There it is. and this new copy should look about the same. I'm going to make it one more time, hopefully cleaner. Well, anyway, it should be the same shape. Not focusing on perfection, focusing on, do you know where that shape will now be? So this is our 90-degree clockwise turn around the origin. All right, so now we have our 90-degree counterclockwise turn around the origin. A 90 degrees counterclockwise is the same thing as a 270 clockwise. If I make an image similar to what I did on the last slide, I could have a grid like this. We'll put X here. This time, we're going to make a turn that goes the opposite, counterclockwise. But it's the same thing as saying 270 clockwise. It puts it in the same location. To do this, we're going to switch the order of our numbers again, but this time we're going to change the Y into the opposite sign. Let's do that with E, F, G below. E prime, we need to first swap the numbers, but let me go back in because the Y, which was -2, is no longer negative, it becomes +2. Let's look at that again for F. F prime will be at -5, -6. Keep in mind again, I had to change the sign. And then G prime, I need to change the Y again to -2, 0. Now let's put this on our graph to the right. This shape is mostly in the second quadrant. And if we're going counterclockwise, it would be my guess that the majority of our shape is going to end up down in that third quadrant. So I first start with E prime, which is at 2, -3. Then I have F prime at -5, -6. And then G prime at -2. I should get a right triangle that looks similar to the one already pictured. Those are our two 90-degree turns. Our last one is going to be a 180-degree rotation. Now for 180 degrees, the direction does not matter because no matter which direction we go, our shape ends up in the same spot. I will show that again off to the side. If I just say put something over here in the second quadrant and I go 90 degrees counterclockwise, I end up in the fourth quadrant. And then 180 degrees clockwise, I end up again in that fourth quadrant. To do this, all I need to do is change the signs of the ordered pairs to their opposites. So any positive becomes a negative, any negative becomes a positive. Let's go ahead and move the square here to its new location 180 degrees away. First, we'll find Q prime, which is now at 8, 2. R prime, which is at 8 and 9. S prime, which is at 2, 2, and T prime, which is at 2, 9. And now let's graph. Q prime is at 8, 2, and R prime is at 8, 9. S prime is at 2, 2. And T prime is at 2, 9. And what I misspoke earlier was this is not a square. Really close, but it is a rectangle. That is our 180-degree rotation about the origin.